Good morning or afternoon, depending on when you're watching this. Welcome to Unit 6. Unit 6 is a little bit tricky, so I've created this foldable for you to help you organize your thoughts, organize the skills that you're going to need in order to solve rationals or simplify rationals. So please follow along inside of your foldable notes here. We'll flip up to the first page in the book, Factoring Review. In this case, what we're going to do is we're going to take a look at how to factor when you have your value of your x squared coefficient is equal to 1 and when it's greater than 1. Once we get through this part, I strongly recommend to you that you pause and try to factor it before I do, and then check your work to make sure that you've done it properly. And our second one . At this time, I strongly recommend that you pause the video, follow these 4 steps, and solve or find your factored form of each of these two expressions. Alright, these are the steps that you should have taken in order to solve it. Number 1, find the GCF. Number 2, we'll be splitting the middle term. It's at this point, whether you box or whether you use the AC method still, that you would draw your box. I'm simply going to use my grouping method here. If you are familiar with and like to use this to help organize you, the last term goes in the top, the middle term goes on the bottom. The two numbers that multiply together to make 6 and add up to 5 are 2 and 3. You regroup it in either order, it does not matter, but we're splitting 5 into 2 numbers. We've split the middle term. Now we're going to focus on what's inside the parentheses, do some 4-term grouping here. And we take the GCF of each of these groups separately. Remember, this is your checkpoint. These two are the same, so that's your first factor pair, or binomial, sorry. And what's on the outside of parentheses is your second one. Don't forget the GCF from step 1, that is part of your factored form. Get into the habit of noticing a factor that will come out before you start factoring, because that makes your problem much simpler. Sorry, that is not the factor that comes out of there. It is simply 2x, leaving you 2x minus 3. Remember, these two symbols don't match, so we've got to take out the negative here, leaving 2x minus 3 in the center. If you were observant, you'll notice this is a perfect square trinomial, so your factored form is going to be this. Remember, that can be written as this. And remember your GCF at the beginning, that is part of your solution. This is going to be a very critical component to everything that we do when we're simplifying rationals. So please have a very good working form of factoring so that you can be successful. Take a moment now to fill in these spaces here. A rational expression is known as a polynomial that's divided by another polynomial. You'll notice in all of your examples, that's what you're looking at. When multiplying and dividing, you're going to follow these steps here. When we get to addition and subtraction later, there will be a different set of steps that we follow, but these are the ones that you're going to use primarily for multiplying and dividing. The first thing you're going to do is you're going to factor all polynomials. The second thing you're going to do is cancel identical quantities. Not identical numbers, identical quantities. Okay? And number 3, you're going to simplify by reducing to lowest terms. Now the first thing you're going to want to remember is that each one of the problems that we give you are simplifiable. Alright, so without further ado, let's get started. I'm going to factor the top by using mental factoring. The thing you're going to want to do as much as possible is factor using mental factoring. So the question I'm going to continuously ask myself is, what two numbers can multiply together to make 3 and add up to make 2? So in this case, the numbers I choose are 3 and 1. So it's going to be x minus 3 and x plus 1. I'm going to save myself some time in rewriting this by simply crossing this one off and rewriting the factored form above it. Likewise, I'll do the same here. What two numbers multiply together to make 5 and add up to make 6? Now we get to the part where you cancel identical quantities. The quantities are the values that I have in parentheses. Get into the habit of putting your binomials in parentheses so that you can see clearly that x plus 1 is identical to x plus 1. Remember, this x and this x do not cancel from each other because they are part of a quantity. X minus 3 is different than x plus 5. X minus 3 divided by x plus 5 is the simplified form of this rational expression. Number 2, this is like writing x minus 4 twice. And this, what two numbers multiply together to make 20 and add up to make 9? Careful on your symbols, that's a minus sign, that's why both of those are minus as well. This quantity cancels with that quantity, leaving me x minus 4 over x minus 5. Now we get a little bit more complicated, but it is the same process every single time. So I'm going to take a look at all of these numbers and see how they reduce. Notice properties of exponents is going to play a very large role in question number 3. So 12 divided by 6 is 2. So what I'm going to do is I'm going to write a big empty fraction bar, and I'm just going to start putting values either on the top or the bottom based on where they go. Starting with the numbers 12 and 6, I will reduce that to 2. This x and this x subtract from each other. 5 minus 2 is 3. There's more x's on the top, so it remains on the top. Cancel those out so that I know I'm done with those. These two numbers subtract from each other as well. 4 minus 2 is 2. There are more y's on the bottom, which is why it goes down there. Cross those off so I know I'm done with them. 9 and 3 reduces to 3. Cross those off. This subtracts to make x, more x's on top. This subtracts to make y squared, more y's on the bottom. Now I've got one more step to take here. I'm going to go ahead and give myself some more space to draw a new fraction bar with. And let's simplify our numbers first. 2 times 3 is 6. x and x makes a total of 4 x's, x to the 4th power. Y squared makes a total of 4 y's, y to the 4th. There's my simplified form of that particular rational expression. Question number 4, back to factoring. The greatest common factor of these two numbers is 2. X minus 1. This does not simplify. I'll simply make it a quantity so I remember to cancel identical quantities. The most used factoring trick, the difference of squares. X minus 4, x plus 4. Please be able to recognize that. That'll be the one that you see the most often. This simplifies down to x minus 1 and x minus 2. Now we're going to take a look at all of my identical quantities and cancel the ones that do. X minus 1, x minus 1, x plus 4, leaving me 2, x minus 4, and x minus 2. Be very observant. Don't miss any of the parts that you did not cancel, because that will affect your final answer. Question number 5. One last time, GCF here is going to be 2, x plus 7. GCF here is going to be 2, and that's x squared minus 25. Oh, there's that factoring trick. So I'm going to cross this off one more time and rewrite it as 2 times x minus 5 times x plus 5, difference of squares. Back up here, GCF of 8, leaving me x plus 5. GCF of 6, leaving me x plus 7. All right, cancel party, here we go. So I get that crossing out with that. This 2 reduces with that 2. 5 and 5. And now what I've got left is 8 over 6 and the x minus 5. 8 over 6 reduces to 4 over 3 times x minus 5. Your turn to practice. Questions number 6 and 7 are yours to do on your own. Please take the time to do them now and be ready to share how you got your solutions tomorrow at the beginning of class. A hint has been given to you. Keep, change, flip is the way you're going to deal with this division problem. So I want you to explore that to see how it is that you find the simplified form of that rational expression.